Hi everyone, our team is called Team Aquabots. We design a group of robots that work together to help clean and protect our ocean and beaches. Each robot has a different job, like monitoring water quality, collecting trash, and removing oil, but together they make one smart cleanup system. So introduction and problem statements. Harbors and beaches face serious pollution problems, floating trash, fuel spills, microplastics, and degrading water quality. Current approaches are limited. Many devices only clean trash, others sample water manually, or require heavy human effort. Our team solutions a fleet of coordinated robots that monitor, clean, and continuously maintain a coastal environment.
How teams robots target audiences and the problems they face are local municipalities and local communities. They suffer from high cost, public pressure, limited staffing, and typically inconsistent and limited funding. Marina managers, port staffs, they face similar issues. They have labor intensive cleanup issues, and they disrupt daily operations where their current workers cannot continue to do the jobs they need to do otherwise. Coastal conservation organizations lack scalable and cost-effective cleanup and mitigation tools. They're struggling. They're trying to get by with what they can with limited resources they do have. Local business owners, they face health hazards, reduction of customers, and pressure from local agencies. The health hazards are more immediate and necessary to be taken care of right then, right there, and can't be ignored because if they do not, obviously customers are going to stop coming. And if someone, say a customer gets sick, they now have to deal with the issues that come with that.
So the first robot will be the water quality monitoring robot, which is mine. And I show you and how it moves in the water. And then I'll show you the simulation of the robot. So when you click, when you type go on the serial monitor, it will go. The propeller will move forward. It's equipped with the sensors to measure pH, turbidity, and temperature, give us a real-time environment data. And it uses 3 ultrasonic sensors, left and right, back, detect obstacles and avoid crashing into things. Its 2 propellers allow it to move forward, turn, and reverse as needed. Yellow lights, LEDs indicates its states: blue when idle, green while scanning or moving, yellow when battery is low. So I'll just type low bat on the serial monitor and it will turn yellow. So Aquabots, water quality monitoring robot, sends the sensor data via LTE, GPS to the operator or system, so we can make a data-driven decisions about cleanup. In the system coordination, Aquabot does the scouting first, mapping which areas needed cleanup, and guides the other robots to skimmer, oil observer, beachcomber to where they should go next. So and this is the flow chart of the robot. Start on, initialize sensors, LED blue light on for idle, operator go, command yes or no. And yeah, so let me now move to how our 4 robots coordinate in the system.
The surface skimmer robot. This robot will be on a docking station waiting for the water quality control robot to send its GPS location for the area need to be cleaned. Once that GPS signal is received via this little GPS on top, it'll be placed into the water. Once in the water, it will then skim using this V-shaped hull, which will trap the floating debris. It'll go then into this basket, here, which has a pressure plate down here at the bottom. Once that pressure plate reaches 2 pounds of debris, it will light up this red LED light, letting it know the basket is full. It needs to be back to the docking station to be emptied and then returned back to its location where it last cleaned.
My robot was designed to be relatively small and buoyant, allowing it to carry as much oil as possible so it does not have to return home super often if a larger oil spill does arise and it is used there. Its small stature allows it to be very nimble and capture oil in small spaces, such as corners where oil may gather around docks and boats and whatnot. The robot features dual thrusters, allowing it to be nimble and get in those corners where oil may be located. When the oil is scraped off the rotating drums, it will be placed into a temporary holding bin, where then a oil pump will then pump it into the permanent collection tank to be emptied by the home station. The robot will hold roughly 6 pounds or a gallon, depending on how much water is included in the oil mixture. A simple red LED is used just to indicate activity being sent or received from home station, just as this to help basic troubleshooting to make sure it's connected properly. Real-time information is sent and received from the home station. The home station will be able to monitor its current location and tank weight. The robot follows a very simple and basic flow chart. It'll receive where it needs to go, its dedicated waypoints, its location. It'll set off, and it'll continue to complete said route until the storage tank is full, in which case it'll head home, be emptied, and then sent back out, and it'll return to its last known location where it was empty and can finish the route, or when it completes it and it's not full, it'll just go home and then await to be resent out by the home station.
Hi everyone, I'm Skylar Meidler and I designed the Beachcomber robot. This robot is truly robust in design and logic, ensuring our beaches, lakes, and ocean floors are free from microplastic debris. The bot's carefully defined logic controls 2 motors used for navigating GPS coordinates, while 2 IR sensors prompt plastic-specific analyses, thereby controlling all 5 non-navigation motors based on signature wavelength readings. 2 of these motors control grate covering, opening, and closing, while the other 3 control trapdoor functions for debris removal. Additional components consist of an LCD display that provides real-time feedback, including the current path number, batch number, battery life, the weight of the collected plastics via a force sensor, and more. Warning messages may also be displayed for clear user understanding. And finally, the bot's movement is designed to handle obstacles and traverse any environment with ease, using tank-style treads and specially designed claws. And movement adjustments allow the bot to correct its course if stuck. So why choose us? Well, we offer a fully integrated environmental solution to one of the world's biggest problems. By combining real-time water quality monitoring, surface debris removal, oil spill response, and microplastic capture, we're tackling marine pollution from every angle. Investing in us means investing in cleaner oceans, smarter data, and a sustainable future.
The Aquabots system provides a coordinated and effective solution to water and beach pollution through 4 specialized robots: the surface skimmer, oil observer, water quality monitoring robot, and microplastic beachcomber. Together, they meet and design requirements by cleaning debris, absorbing oil, monitoring water quality, and collecting microplastics while operating autonomously for several hours. This system fills the gaps in the market where existing products like Seabin and Waste Shark focus only on one single task. Our integrated approach reduces labor and maintenance costs while providing continuous real-time environmental data. By combining multiple functions into one coordinated system, Aquabots offers a scalable, cost-effective, and sustainable solution for harbors and beaches. And here are our references.